Hello guys, welcome to my YouTube channel. From now let's start learning together with me and welcome to Learn with me. Now let's start our lesson. C programming. The topics which we are going to study are 1. Introduction to computer and computer languages, 2. Introduction to C language, 3. Input and output functions, 4. Operators and expressions, 5. Statements, algorithms and flowcharts, 6. Decision-making and branching, 7. Repetition or looping, 8. Functions, 9. Arrays, 10. Strings, 11. Recursion, 12. Pointers, 13. Structures and union, 14. File handling, 15. Preprocessors, 16. Introduction to data structures. Now let's start our first chapter. Introduction to computer and languages. Introduction. Computers are being used everywhere in homes, offices, automobiles, schools, colleges, shops and so on. Nowadays majority of human beings from kids to old people, whether literate or illiterate, talk about computers, and computers. What are computers? A computer is an electronic device that is used to accept the data, process the data and give the desired information. It can perform calculations, store information and execute various tasks with high speed and accuracy. Computers consist of hardware, physical components, and software, programs and applications, and are used for tasks like data processing, communication, entertainment, and automation.
What is program? It's a set of instruction given to computer to achieve a specific task is called a program. Why should we learn the programming languages? 1. We people communicate with people using languages like Kannada, English, Telugu. Similarly, we can communicate with computer by giving instructions. 2. These instructions that are given to computer to do a specific job. 3. The person who writes a program is called programmer. 4. The language which is used to write a program is called as programming language. What are the different types of programming languages? Machine-level language, assembly-level language, high-level language. Now let's move on to the first topic. Machine-level language. It's the set of instructions given to computer in the form of zeros and ones. This is the language of computers. Various operations can be performed by combinations of zeros and ones. Now let's see on of the example how the machine language works. Example. For performing addition of two numbers. 0 plus 0 gives 0. 0 plus 1 gives 1. 1 plus 0 gives 1. 1 plus 1 gives 2, which will be written as 1 0 in the form of binary. Now let's consider the following numbers 1, 1, 1, 0 and 1, 1, 0, 0. Now let's add the digits 1 by 1. 0 plus 0 gives 0. 1 plus 0 gives 1. 1 plus 1 gives 2, which is equal to 1 and 0. Now let's write 0 and take 1 as carry. Now 1 plus 1 plus 1 equals 3, which is equal to 1, 1. Now let's look at some of the advantages of machine-level language. Advantages. 1. Program execution is very fast, as the computer can understand and execute machine language. Translator such as compiler is not required. Disadvantages. 1. Difficult to remember the machine instructions. Let's consider an example. Adding the numbers 5 and 3. Basically we humans directly add the 5 and 3. Now we write the assembly level code for adding the numbers. Assembly code MOVA, 5. Here in this instruction 5 is moved into register A. MOVB, 3. Now 3 is moved into register B. Add A, B. The addition of A and B is done as instructed in the code, then the result is A. So now let's move on to machine-level code, which will be written in the form of ones and zeros. Machine code, binary code. 000100100101 here loading of 5 in A. Can be seen. 000100100011. Loading of 3 in B. Sum of A and B is finally obtained. It's hard to remember because machine code is just numbers, assembly is easier. 2. Difficult to read and write machine language programs. As we have taken an example previously, we can observe that remembering zeros and ones is quite difficult job. 3. Very difficult to debug, correct and modify. 4. They are machine dependent and not portable, which cannot be adaptable across the platforms. 5. It is unstructured language, which is free form and often chaotic, lacking clarity or order. Assembly-level language. Symbolic names are used to represent an instruction instead of zeros and ones. For example, add R1, R2. This instruction tells that the values R1 and R2 to be added. Thus, instead of zeros and ones is machine language. We can write the instructions using symbolic names such as ADD, SUB, MUL, DIV. It is also called as symbolic language. These symbolic names are called mnemonics. This makes assembly language easier to read and understand when compared with the machine language.
Assembly-level language can be defined as: assembly language are also called as symbolic language, which is nothing but the set of instructions given to the computer in the form of symbolic names. The symbolic names are also called mnemonics. Advantages: 1. Easy to remember the symbolic names and there is no need to remember the machine code. 2. Program understanding, correction, modification is relatively easier when compared to machine language. 3. The language is simple and easy to write when compared to machine language. 4. The execution speed of program written in assembly language is same as that of the equivalent program written in machine language. Disadvantages: there is a need for translating the assembly language program into machine language program. It is machine dependent. It is an unstructured language, difficult to understand and debug when compared to higher level languages. There are translators which convert assembly language into machine language. This translator is called assembler. Now let's take a look at the assembler, which is known as translator in the assembly level program. Basically, the assembly language program is written. Let's consider an example: add R1, R2. Then in the next step follows to the assembler or translator. The R1 and R2 is basically converted as, for example, MASM. Then in the next step the assembler converts it into machine language, which is in the form of zeros and ones. Example: by this flowchart we can define assembler as: an assembler is translator which translates the program written in an assembly language into the machine language, helps computer to understand the given instruction. Now let's move on to our next topic: high-level languages. This enables the programmer to write machine-independent code. They are easy to read, write and maintain. These programs are portable, that is, they can be moved and run on computers of different manufacturers. Now let's consider an example. Void main, int a equals 10, b equals 20, sum. Sum equals a plus b, print f, sum equals %d, sum. For easy understanding of the language, comments will be written beside the program. Int a equals 10, b equals 20, sum. This line represents the instruction as value of a equals 10, b equals 20. Sum equals a plus b. Represents add value of a, b and store in sum. Printf, sum equals %d, sum. Represents print the result on the screen. Now let's move on to the advantages and disadvantages of the high-level languages. Advantages: 1. They are easy to understand. 2. Easy to read, write and modify. 3. The code is very compact and self-explanatory. 4. They are machine-independent programs. Let's move to the disadvantages. 1. Takes more time when compared with machine language or assembly language, as the machine has to understand this high-level language conversion of the language is done. So translator is required to convert the programs written in high-level language to machine language. This translator is also known as compiler. This compiler converts high-level language program into machine code or object program. The compiler is a translator which accepts the program written in high-level language and produces the corresponding machine language program or machine code. After accepting the program written in high-level language, it checks for the errors in the given program. If any errors, the compiler displays the appropriate error messages along with the line numbers. The programmers can correct these errors and repeat the compilation process. This process is repeated as long as there are no errors in the program. And when there are no errors in the program, the compiler produces the machine code. The commonly used compilers are Turbo C, Visual C or C++. Now we have completed the types of languages. Let's move to the next topic: how to create and run the programs. Creating and running programs. Here it involves majorly 4 steps, which are as follows: writing and editing programs, compiling programs, linking programs, program execution. Now we will see each step in detail. Now let's start with the step 1. Writing and editing programs. The software that we use to type a program is called editor. By using text editor we can enter or type the program, change and store the program. Step 2. Compiling programs. Once we type the program, it has to be converted into machine language. This can be done by pressing the key Alt plus F9 in Turbo C. Step 3. Linking programs. From this example, we have used one function by name, printf. It is object code and we have created another object code in the previous step. These will be combined to form executable code. This is done by linker by giving the following command: Ctrl plus F9. Step 4. Program execution. The program is executed and we get the result on the output screen. Now let's move to the next topic: essential computer software. A program is a set of instructions given to the computer to perform some specific task or activity. The set of programs that does the specific jobs are called software. Using the software, computer can receive the data, store the data, manipulate the data and output the data in correct order and format. Software can be classified as system software. Example: operation system. Application software. Example: MS Word. Let's see each of them in detail. System software. The program that support the operation of computer are called system software. The system programs help the user to utilize the various resources of computer system effectively and efficiently. The main purpose is to help the user to use the computer system efficiently. Example: operating system. It is a set of programs that help the user to interact with various resources in the computer system. Example: Unix, Linux, Windows Vista, etc. Application software. The set of programs which are developed only for the specific need from the customer are called application software. Example: ticket reservation software, payroll software, software for library management, student information management. These serve only the specific interests. This ends the first chapter. Don't forget to like, share and subscribe, and do support Learn With Me channel. For more updates and doubts in the class, let me know in the comment section. Thank you. Have a good day.